So it's good to see you all again. I'm Natasha and welcome back. So I hope you all are fine. So today we're going to continue our chapter number 2, relations and functions. So in the previous video, we discussed about real valued function and real function. So in this video, we'll be discussing about some functions and their graphs. So, overall I'm going to say that we're going to discuss some types of functions. So let's get started. Okay, so first function that I'm going to say is, first I'm going to say is identity function. Identity function. What is identity function? And how is the graph going to be of it? So first of all, let me write the identity function. Identity function. Identity function. Oh, what did I? Function. Yeah, I was saying actually function. Identity function. Okay, this is correct. Yeah, so what's the identity function? So it is a function that rewards the same value. So what does that mean? And what does it mean by the same value? So identity function is a function which returns the same value. So now, what value will it be? Will it be input value or output value? So first of all, the both values. So you know that, it's mainly talking about the output. So the same output that we're gonna get. So the same values may, that simply means that it is a function which returns the same value. So identity function is a function that returns the same value. So let me just write the small statement. It's of course a definition. So then we'll discuss more about it. Okay, and then we'll look after its graph. Okay, so it is a function which returns the same value. The same value. Okay? So it is a function which returns the same value. So, and the graph's going to be like this way. So first of all, a graph we have usually is like this way. Okay, so we have two axes for now, x-axis, negative x, and y-axis, and it's gonna be its it's negative y, okay? So these are the axes that we have, and we have one more axis that is z, which is gonna be right here, but we're not gonna discuss about that. We're just going to look after these two x's. That's it. And and they're negatives too. Okay, so the graph's like this way, and let me just draw the number line, the numbers here, and okay, so this is gonna be our origin, 0, 0, which we can say. So here I'll write 2, 4, 6, 8. You can take any pattern, and so that okay, so let me just take simple numbers, okay, so that none of us will be confused. Okay, I'm gonna take simple values, just simple numbers. Okay, so I'm gonna say 1, 2, 3, 4. That's it. Fine. And now let's take it in the negative 2, negative 1, negative 2, negative 3, negative 4. And here we're also going to write the same, negative 1, -2, -3, -4. Okay? Okay, so yeah, I can also say, but I'm just gonna, leave it like the way it is. And here I'm gonna say 1, 2, 3, 4. That's it. Okay, so let's look at the origin. So what does this identity function mean? So it is saying that it is a function which returns the same value. So it's like reverting the same values. So let's say we have, so as you all know that f of x. So what I'm going to say is that is f of x is equal to y, isn't it? So what I will say is that y is equal to actually fx, as we all know. Okay, so I'm going to write it like that way. That will be more better than this one. Okay, what I will write is that the function we have is r to r. Let's say this is like the real numbers we're having. Okay, so we have a function from r to r, and what's so special in that function is that the f of x is equal to y. Just have a look. As we all know, isn't it? So, but in this value, like in this case, I'm gonna just change it a little, which I'm gonna say that y is equal to fx, okay, fx, and fx is equal to x, So what is this x? So is this, this y is actually the output, and this x is actually the input. So it's saying that it is a function which returns the same value. So what is it saying? That as we know that we have the y is equal to fx, okay, for each x belongs to r. R means the real numbers. Got it? That's it. So it's saying that each x, like each element, like each and every element, x will belong to real number. Okay? Sorry. Yeah. So x belongs to the real number. That's what we can say. And in the identity function, like how is it going to be? So let's say that we have a value like the one we have. So 1 is going to be right here, okay? So I'm going to make a dot right here. So it's saying that it's going to return the same value. So if the fx is here, if the x is here, which means that y will also be its exactly same. So this means if but it's going to be in the negative way, okay? If it's in this way, then it's going to be in this way, because the y we have is here, okay? So if it's here, then it's right same point, it's going to be here, okay? It's going to be right exactly here, okay? And if I'm going to say this 2 right here, okay? Then it's going to be same, like this way. It's too much far. Let's say here. And so this way, through this way, like it's going to make a pattern like this way. Okay? And so this line will be, and this is how a line will be made. This is how a line will be made. Okay? Just like this way. Okay, just like this way, a new line is going to get converted, it's going to get formed. So this is what we have. So if fx is here, then y will also be here. So let me just tell you in an easy way. Let's say we have x, okay? We have x and y is equal to f of x oh my gosh, like, okay, so y is equal to f of x. Okay, this is the more better. This is more better, and fx is equal to x. Okay, that's what we can see. So if, let's say, if the value of x is let me say negative -2, then y will also be -2, as it's going to return that same value. And one more thing, second thing is that y is equal to f of x, and it's actually x is equal to -2, which means that y will also be the same. This is how it's like identity function, in which that function is just going to return the same value, and in the graph, in this form, like it's going to make a line like this way. Okay, if the x value, let's say the -2, let's suppose -2 is here, so it's going to be in the same way. So like, this through this way, it's going to make a line. Okay, this line. Yeah, and if I'm going to say it's -1, then it's also going to be -1. If 0, then this is also going to be 0. If 1, then this is also going to be +1. And if I'm going to say 2, then this will be also 2. Why? Because it's going to return the same value. It's going to give the same value, as the input is, what I will say, that the input will be equal to the output. That's what we'll say. This is what it means, the same value. So it's talking about both the input and output, which is going to, have the same values through identity function, in this function, of course. And about its domain and range. Domain and range, what can I say? So the domain is going to be actually, so one thing's clear, f of x is equal to x. Second thing, that the domain will be all the real numbers that we have, and range will also be all the real numbers. Okay, so what I'll say, domain is equal to r, range is equal to r, which means that's going to be the domain and range. Like, both domain and range are going to be the real numbers. Okay, because like whatever result we're going to get, it's domain and range, like both we can see that there will be real numbers, because like they'll have the same value. So if x is having the real numbers, then y will also have the real numbers. So this is how I can say domain is equal to real numbers and range is equal to real numbers. That's it. Nothing else. So this is what identity function mean. And about this graph is a straight line, as I can see. So the graph is a straight line, okay? As we can see, the straight line. Okay, that's it. Just have a look at these 3 points. Nothing else. Okay, so the graph is a straight line, and the domain and range, both domain and range will be real numbers. And one more thing, that fx is equal to x, which means that this is like through this way how it's going to return the same value. Okay, so that was all about identity function. Now let's move on to our second function. Okay, second function which we're going to talk about is going to be constant function. Okay, so let's talk about constant function. As you all know about constant, what's the constant? So I think you can guess it just simply. I hope you will. So let me just rub it, and so second function, which is going to be constant function. I'm gonna draw the graph also. I'm not gonna rub this graph. Okay. I'm almost done. And let me just rub this straight line too. Just like this way. Okay. Wait a second. Okay, so I'm done, and now our second function is going to be constant function. Constant function. Okay. Okay, so as I said, you'll be able to guess this function, like guessing a little bit, but guessing, it not always works. Okay, so constant function. So what is constant function? Like it's talking about something which is related to constant, which is going to be something like going to be constant. So it is a function that has the same output value. So it is a function which has the same output value no matter what the input value is. Okay? So what it matters to is it only cares about the output value that's gonna come. Okay? No matter what the input value is gonna be. So what I'll say that constant function is a function that has the same output value, and doesn't matter to input value at all. Okay, so it is a function. It is a function that has the same output value. There's no need to write this statement. I've already said this. Okay, so it is a function that has the same output value. Output value means the range, of course, the range. So it is a function that will have the same output value no matter what the input value is. So let me just tell you in an easy way. Here we have x, here we have y, and y will always be f of x. So f of x, okay, fx. So if x is gonna be, and remember this is our, wait a second, yeah. Remember this is our input value, and this is our output value, okay? Just remember this thing. Okay, so x is the input value and the y is the output value. So what I'll say is that, if let's say that the value of x is -2, and f of x, fx, and fx is equal to 3. Okay, let's say fx is equal to 3. Got it? So if fx is equal to 3, this means that y will be 3. Doesn't matter to the input value. Even if I'm going to say 0, it's still going to be 3. Even if I'm going to say 1, it's still going to be 3. Even if I'm going to say -1, still it's going to be 3. Because it's the constant, like it's going to be like if fx is equal to 3, which means that it will have the same output value. That's it. Doesn't matter to the input value, like whatever is it, even if it's -2, 0, +1, +2, or anything else, the output value will be same, okay? As it's already mentioned, fx is equal to 3. Okay, so this is how the constant on the graph, it's going to be like this way. Just a straight line going, let's say, from here. Okay, a straight line just going from here. So this is the line. This is what I can say. It's gonna be constant. which stays constant, okay? Doesn't matter to the input value, whatever the input value is, that doesn't matter. Okay? So, it is a function that has the same output value, no matter what the input value is. That's it. Okay, so if I'm going to talk about its domain and range, so maybe it's going to be clear to you, a little clear to you. So, what it's going to be like, let me take a small example. Like, it's not like exactly going to be as an example, but let's say it's as an example only, okay? Okay, so what I'm going to say is that fx is equal to c, where c is a constant. Okay, so let's say fx is equal to c, and c is a value, you know, if it's 3. So it is saying that fx is equal to c, where c is a constant. That's one thing, just permanent, that's compulsory, and like that's fixed, okay, that's fixed. C is a constant, which means that the output value is always going to be c. But if I'm going to look at the fx is equal to 3, then it's going to be always 3, you know, as I've used the value, okay? And one more thing is, before like, you know, let me just rub this. One more thing, that the input value, will always belong to the real number. So, the x belongs to the real number, where, now I'll say that where c is a constant. Just remember it. Okay, so in the place of c, I put the 3, okay? So fx is equal to 3, and that's what I've just written here. So the output value is going to be 3. That's just fixed because we have an output value. Okay? No matter what the input value is. This is just, you know, like, we have to just keep it in our mind. Just to, you know, like not to forget it. And about the second thing, that's about its domain. Like, I'm going to say this as a point related to this graph. And the second one I'm going to say is domain. So domain will be the real numbers. And range. What's going to be the range? According to this graph, according to this value, range is only going to be 3. As we already have an output value. So which means that range is going to be 3 according to this graph. That's fixed. But about the domain, it can be any real number. So domain is equal to the real numbers, but the range will be, you know, the output value. Like if I'm going to say it through this way, then the c will be here. Let's say c, okay? So range is equal to c. That's fixed because we know that c is a constant. So the range will be c, nothing else. So, and yeah, well, this is a singleton set. As we can see, there's only one element here, okay? So, and about the graph. So, what's similar to the graph? To the line. The line is like parallel to the x-axis, as we can clearly see. So, the graph is a line parallel to the x-axis. The graph is a line parallel to x-axis, okay? X-axis, got it? So this line, the line we have here is parallel to x-axis, as we can clearly see. Okay, so that's it about the constant function. Constant function was really easy to understand, like, you know, it's all about the output, nothing about the input. What do we have to just remember in the constant function? That it has the same output value. That's it. And the domain will be the real numbers, but the range is going to be only the output value we have. Okay, so let's move on to our third function, which is a polynomial function. Polynomial function. Have you heard about this function? If not, then let's discuss about it. Okay, I'm again rubbing the board. Polynomial function. I think you already know about polynomial, isn't it? We've studied about polynomial in earlier classes. So it will be easy to understand, like constant function and identity function also. Okay. So I'll rub the board, and now let's move on to our third function, which is polynomial function. Polynomial function. Okay, so what is polynomial function? Polynomial function. And let me do the graph also. Okay, it has two axes, x-axis, y-axis, negative y, and negative x. Here we have 1, 2, 3, 4. Here we have negative 1, negative 2, negative 3, negative 4. Here we have negative 1, negative 2, negative 3, negative 4. Let's say here we have also negative 5. Okay? And here we have 1, 2, 3, 4, and 5. Okay? Let me write it just a little. Wait a second. 4, 5. And this is our y-axis. Okay, and here we have our origin, of course. Okay, so this is the graph and the polynomial function. So we're going to discuss about polynomial function. So polynomial function is a function in which the independent variable is a part of a polynomial. So a function which involves only non-negative integers. So what I will say that it is a function which involves non-negative integers. So it is a function which involves so it is a function which involves the non-negative integers, okay? So, it's like you're talking about an independent variable. So, a function in which the independent variable is a part of the polynomial, expression we have. As you all know about polynomial expression. So, this is like an independent variable is a part of the polynomial expression. So, and in this function, it involves, the non-negative integers. That's it. Okay, that's it. So, let's have a look at it in the graph, in its graph. Oh, sorry. For the polynomial function, like, I don't need to show its graph. Okay. In the polynomial function, it's just really like easy. So there's no need to show it in a graph, okay? So, what was I saying about polynomial function is, I'm going to take a few examples related to it, okay? Okay. For example, y is equal to 2x squared plus 4, not y. Let's take the x. 4x plus 5. So like this is like a simple example. So the y-axis, the graph I've just rubbed it because I thought that there's no need to show it in a graph. So the y-axis, so the y-axis, so y is going to be the output. So that it's saying that the output value is equal to 2x squared plus 4x plus 5. Okay, and the x x and y, which is going to be always going to be there in functions. So x is going to be the input value and y is going to be the output value. That's what it's talking about. So we'll discuss some further details about polynomial function in our next video, okay, or maybe in another video, okay, but not now, okay. Got it? So let's move on to our third function, okay. I've been saying a lot of okay. Yeah, so let's move on to our fourth function. It is rational function. Rational function. What is rational function? Rational function. Rational function. Okay, so what is rational function? So it is the ratio of two polynomial functions where the denominator polynomial is not equal to 0. Got it? So it is the ratio, I'm going to write it. It is the ratio, it is the ratio of two polynomial functions. Yeah, it is the ratio of two polynomial functions where the denominator polynomial is not equal to 0. Okay? So it is the ratio of two polynomial functions where the denominator polynomial is not equal to 0. So what does this mean? Like, what does this mean? So it's just really simple. So it is the ratio of two polynomial functions. So it is saying, so rational function is related to polynomial function. So, sorry. Yeah. So, it is talking about the ratios. So, rational function tells us the ratio of two polynomial functions. And one more thing is that the denominator polynomial is not equal to 0. So, it's like never going to be equal to 0. So, the denominator polynomial is not equal to 0. So, let's say an example. Okay. For example, let's say we have fx upon gx. Just have a look. Fx upon gx. Okay? Where fx and gx are polynomial functions, and gx is not equal to 0. Just have a look where fx and gx are polynomial functions and gx is not equal to 0, as we have already discussed about that thing in the definition, in the statement that is just written above it. Okay, so it is saying that we have two polynomial functions. So fx and gx are two polynomial functions, and one thing that is fixed and that is permanent, that gx is not equal to 0. This is one thing. Okay, this is one thing. And if I'm going to talk about it in the graph, rational function in the graph form, then I'm going to say that, some few examples, like first one I can say is x squared plus 4x minus 1 upon 3x squared minus 4x. So 3x squared minus 4x, let's say, plus 2. Okay? So x squared plus 4x minus 1 upon 3x squared minus 4x plus 2. So one thing that we are going to keep it in our mind, that the denominator function, the polynomial function, is not equal to 0. That's it. Okay? So let's have a look at it in graph. Okay. A small graph where we're going to have x-axis, y-axis, negative x, and negative y. Okay? Okay? 1, 2, 3, 4, 5. Here 1, negative 2, negative 3, negative 4, negative 5. In here, negative 1, negative 2, negative 3, negative 4, and negative 5. Okay? And here we'll have our origin. And here I'm going to say 1, 2, 3, 4. Okay? And yeah, here if I want to write 5, I can. 5, and that's it. Okay, so we have, I've drawn the graph, and here we have x-axis, positive y, and negative x and negative y, okay? That's like common, okay? No need to tell it. And that's our origin. And so for the rational function, like how is it going to be? How is it going to be, the rational function? If I'm going to say that the rational function is kind of like in a different way. Okay, let's say, oh, wait a second. Wait a second, please. Okay. Yeah, so let's continue. Actually, the camera was actually, was shaking a little bit. Now it's like, I think it's now comfortable. Now everything's fine. Yeah, so let's say that fx is equal to 1 upon x, okay? Fx is equal to 1 upon x. This is one thing that we have to keep in our mind. So how is it going to be? So it's actually going to be like this way. Okay? A line will be drawn like this way. Just like this way. Okay, these two lines which are joining. Like from the negative x to the negative y, and positive y to the positive x. Like through this way. So fx is equal to 1 upon x. So what does that mean? Okay, so let's say that I have x and y, which is of course will be equal to fx. Okay, fx, got it? So fx. Okay, and let's say the value of x is I'm going to say negative 1. So one thing that you have to keep in our mind, that x is not equal to 0. One thing that you have to see, and we'll have to remember it, so that the denominator polynomial is not equal to 0. So if I say that my x value is negative 1, then what's going to be the output? What's going to be the output? Can you just guess it? Okay, so if like, okay, let's take another number. Okay? -2, is it okay? -2, so we're going to go with the -2. So -2 is actually going to be -1/2. That's it. You know, it's really simple. It's really simple. Okay? And if I'm going to say that, okay, let's say 1. Okay, 1. So 1's going to be 1/1. Isn't it? No? Okay, then let's take any other number. If like we're confused just a little. Okay, -2 we have, so let me take 4, okay, 4, let's take 4. So 4 is going to be 1/4, and if I'm going to take 7 is going to be 1/7, okay. This is the one thing that we'll keep in our mind, okay, like just like the way the -2 was with the -1/2, for 1/4 and 1/7. So this is what the value is going to be according to this value. Okay, according to this value. And if I'm going to talk about the domain and range, what is it going to be? What will be the domain and range of it? Can you just like guess a little? Actually, one thing that I want to tell you about domain and range, both domain and range depends on fx. So, what I will say is that domain and range depend on fx. Okay, just have a look. Domain and range, like both depend on fx. Got it? Domain and range, it's that point. So domain and range both depend on fx. So if I'm going to talk about the domain and range, they will both depend on the fx. Like what's the value of fx? If it's like according to 1/x, then it will be something different. Okay? And this is how the examples will be. Okay? So that was all about racial function, and like as I've told you that we're going to discuss about polynomial function in more detail, but in any other video or maybe next video. So there are like some few more functions that we're going to discuss about, but that's all for today. So in the next video, as I've just told you, that we'll do the other functions and discuss about polynomial function also. So thanks for watching and have a great day.